Greenland sits on every map as a flawless white slab, vast, blank, almost impossibly flat. Its coastlines are sharp and detailed. Inside, there appears to be nothing, as if the world's largest island is hiding a secret. Most people assume that emptiness is real, but the truth beneath the ice is nothing like what those maps show. Why does Greenland's map erase all its mountains and valleys, and what does that illusion cost us? A digital map of Greenland pulls you in with sharp, confident lines along its coast. The shapes are crisp, the edges certain. But as the view drifts inland, detail dissolves. Towns and fjords vanish, replaced by an endless, untouched white. No rivers, no hills, no sign of anything at all. The world's largest island, and yet its center is a blank so complete it almost feels deliberate. Zoom in, and the emptiness only grows. The white remains, stubborn and silent, while every other place on the planet bursts with color and texture. Roads thread through Europe, forests crowd Canada, deserts ripple across Australia. Greenland alone holds its silence. The coastline stands out in perfect contrast, as if the map knows only the rim and refuses to guess at what lies inside. It is an odd emptiness, not the busy clutter of missing data, but a smooth, featureless void. With every click, the sense of mystery deepens. Why does the map show nothing where the heart of Greenland should be? The absence is striking, almost haunting, a white so pure that it dares you to imagine what is hidden underneath. Beneath. Greenland's endless white lies a world that almost no map reveals. The island's interior is anything but flat. Hidden under up to 3 kilometers of ice, the land rises into mountains and plunges into deep basins. Radar and gravity surveys show a dramatic landscape. Peaks like Gunnbjornfjeld reach 3,700 meters above sea level, while valleys and canyons drop more than 2 kilometers below. In fact, about a third of Greenland's bedrock sits lower than the ocean. The ice sheet itself holds nearly 3 million cubic kilometers of frozen water, pressing down with such weight that it actually dents the land beneath. If the ice vanished, Greenland would look nothing like the smooth white mask seen on digital maps. Instead, it would reveal a rugged spine of mountains, vast gorges, and even areas that would flood with seawater. The illusion of flatness comes from the ice, thick enough to hide every contour, smooth enough to trick even the sharpest satellites. The real Greenland is wild and uneven, its true shape buried deep below the surface, waiting for the right tools to bring it into view. Every digital map starts with a choice. Map makers must decide whether to show what they know, or to keep things simple when the data gets tricky. Greenland's interior is a prime example of that decision in action. Mapping services rely on satellites to chart the world's surface, but ice throws a wrench into their plans. Unlike bare rock or soil, thick ice acts like a mirror for radar and laser signals. Instead of passing through to reveal the true ground below, most signals bounce right back from the surface, leaving the hidden mountains and valleys untouched. What the satellites capture is the top of the ice sheet, a smooth, gently domed expanse. The real landscape, buried beneath up to 3 kilometers of ice, remains real and invisible to most sensors. Faced with this challenge, digital platforms like Google Maps and Apple Maps make a practical choice. Rather than risk showing misleading or incomplete details, they present Greenland's interior as a blank or uniformly white space. The coastlines, where the ice thins and the land breaks through, get sharp detail. But the vast frozen heart of the island is rendered as a featureless void. This is not a glitch or a secret. It is a way to avoid cluttering the map with guesswork or errors. The same approach applies to other remote ice fields around the world. When data is thin, the map stays quiet. These decisions are driven by both technology and design. Detailed elevation models require enormous amounts of data, and processing that for every zoom level or device would slow things down for everyone. So map makers trim away complexity in places where satellites cannot see, focusing resources on the parts of the world where people live, travel, and ask for directions. In Greenland, that means the white stays white, and the mystery remains, at least until new data fills the gap. Centuries before satellites and radar, map makers faced a world full of gaps. Greenland's coastlines were known, traced by Norse sailors and whalers, but the island's vast interior remained a riddle. Without first-hand knowledge, cartographers leaned on imagination as much as observation. Old maps of Greenland often bristled with invented mountain ranges, winding rivers, and even mythical lakes, all filling the blank spaces that explorers could not reach. Gerardus Mercator's famous map from 1569, designed to guide ships across the globe, stretched Greenland into a massive, distorted slab near the top of the world. The Mercator projection, still the default for many digital maps, inflates polar regions to keep compass bearings straight, making Greenland look as big as Africa, though it is actually about 1/14 the size. Mercator makes the distortion visible. For centuries, the unknown heart of Greenland was a canvas for speculation. 18th century atlases show a chain of mountains running straight through the island's center, while others imagine a network of rivers or even a vast open sea. These features were not secrets, they were placeholders, a way to make the map feel complete. As one cartographic historian explains, mapmaking was an act of interpretation as much as measurement. You filled in the blanks with what you hoped or feared might be there. Contrast that creative urge with today's digital silence, where old maps overflowed with invention. Modern platforms choose caution. Rather than guess at what lies beneath the ice, they leave the interior empty, trading imagination for restraint. The result is a new kind of mystery. Not the clutter of fantasy, but the starkness of omission. Empty space now feels deliberate. Mapping Greenland has always meant deciding how to handle the unknown. The tools have changed, but the challenge remains. The land beneath Greenland's ice does not sit still. Over tens of thousands of years, the sheer mass of the ice sheet, almost 3 million cubic kilometers, has pressed down on the crust, pushing it hundreds of meters lower than it would be without the weight. Glaciologists track this slow-motion sag and rebound with GPS stations anchored to bedrock. These stations record the ground rising by up to 2 centimeters each year along the coast as the ice thins and the earth begins to lift. The process is called isostatic adjustment. It is not a sudden bounce, but a gradual, measurable response, evidence that Greenland's shape is always changing, even when the surface looks frozen in time. Life in Greenland gathers at the very edge. Nearly 56,000 people, almost every resident, live along the coasts, clustered in towns like Nuuk and Sisimiut, where the land breaks free from the ice. The interior, covering more than 4/5 of the island, holds not a single permanent settlement. For thousands of years, Inuit communities have relied on the sea and the thin strip of habitable land, building traditions around hunting, fishing, and navigating the shifting ice. The heart of Greenland remains untouched, not because people never tried, but because the ice makes it impossible. On modern maps, this human pattern is stark. All the detail clings to the shore, while the center stays empty. As digital tools grow sharper, the expectation for more names, more roads, more visible life only intensifies the sense of absence. The reality is simple. People live where the land allows, and maps reflect that choice. In 2018, a NASA research plane swept over northwest Greenland, its radar probing through nearly a kilometer of ice. The data revealed a hidden impact crater 31 kilometers wide, buried beneath the Hiawatha Glacier, one of the largest ever found under ice. This was no isolated discovery. Operation Icebridge, flying from 2009 to 2019, traced more than 500,000 kilometers over Greenland, mapping the true contours of the land below. The result is a digital model showing mountains, deep canyons, and basins that would swallow cities. Nearly 3 million cubic kilometers of ice, enough to raise global sea levels by 7 meters, rests above this rugged terrain. What once appeared as a blank white void is now charted in vivid detail, thanks to radar that turns the invisible into mapped reality. Each year, new data from missions like NASA's Icebridge redraw the hidden contours beneath Greenland's ice. As the world warms, our maps will reveal more than outlines. They will expose the changing reality beneath our feet. Sometimes, the most profound landscapes are the ones we still can't see.